Today's our chapter is motion, and we'll discuss the basic properties of the motions, types of motions, and much more. So let us start with the very basic properties of the motion. Motion means what? Any moving object. Moving object. So the moving object, it means if any object is moving, we say motion. So motion are many types. Let us discuss some basic motion properties. First of all, types of motions. So two types of motions we discussed: uniform motion and non-uniform motions. In uniform motions, if object travels equal distance in equal interval of time, object travels equal distances in equal intervals of time. This is known as uniform motion. Similarly, non-uniform motion is when object travels unequal distances in equal interval of time. When object travels unequal distances in equal intervals of time. We can take an example. If here is distance and time, if any object, we plot a graph between distance and time. So in the t equal to 0, the distance is 0. T equal to, this is for second, t equal to 1 second, distance is 5 in meters. This is in meters. Okay, so in 1 second distance is your 5 meter, in next second distance is your 2 meter, and in the next cases distance is 15 meter. This will be. So you can see in every equal interval of time, we are getting the equal distances. 5 meter, if we take a difference is here is difference is 5 meter, and here is also difference is 5 meter. So it shows a uniform motion. Example of uniform motion. ये क्या शो कर रहा है आपको? यूनिफॉर्म मोशन को. Similarly, if unequal distances, in the above example, if distances are not equal, again if you plot a graph, distance and time, so this is your time t. So distance is t equal to 0, time is equal to 0. In t equal to 1 seconds, the distance is your 5 meter. T equal to 2 seconds, distance is your 15 meter. T equal to 3 seconds, distance is your 30 meter. So you can see here in all the cases, in the uniform time interval are uniform. Here is time interval of uniform, here is time interval of uniform, here is time interval of uniform. But in this case, the distance are unequal. In the first difference is 5 meter, second difference is 10 meter, and third difference is 15 meter. So distance in every interval are increasing. It means it is what? Non-uniform motion. This is what? Non-uniform motion. This is very clear for everyone. The uniform motion is what? Where the distances are equal, and non-uniform motion where distances are not equal. So this is what non-uniform motion example. Let us start. We have two types of motions. Is what the speed and velocity. So let us discuss first speed and then velocity. So first discuss with the speed. Speed is what? As all we know, again I'll say, you have you know in the basic classes, speed is what? It is the distance upon time. So we'll make the definition with this formula. And what is it? If the any body travels distances in unit time is known as speed. So I'll write here the object moves distances in unit time. We say distance traveled by object in unit time is known as speed. Very easy to understand. So it means speed is equal to what? Speed is equal to distance upon time. And if time is equal to 1, this time is equal to 1, then speed is equal to distance. So this is very clear to you. And similarly, uniform speed is the same as uniform motion we have discussed just above. Uniform speed is what? Equal distance in equal interval of time. Equal distance in equal interval of time. In equal intervals of time. We have given an example above, so need not be necessary to again the example. Similarly, non-uniform speed is the unequal distance in equal interval of time. So the non-uniform speed, unequal distances in equal intervals of time. Now we have seen the example of this two is already. Let us come to the next definition and we'll discuss with the numericals of this definition. Is what? It is the average speed. Average speed. So average speed is the ratio of total distance upon total time taken. Ratio of total distance. Okay, this is what? Total distance upon total time taken. And we'll make a formula for this. I'll say in short form AVG, average speed, is equal to total distance upon total time taken. So this is good for everyone to by this definition and formula. Let us take an example is here. Question: if a train moves from station A to B with the speed of station A to B with the speed of 30 kilometer per hour and return back to the speed of 40 kilometer per hour. Find average speed. I'll write short form AVG, average speed. Okay, so it is very clear to you, it is not be a normal average of any numbers. It is a total distance upon total time taken. So we will calculate the total distance and total time taken. So average speed, if we calculate here, average speed, total distance from A station to B is, let us assume x, so total distance x plus x, 2x, and total time taken from A to B, speed is equal to distance upon time. So time is equal to speed upon time is equal to what? Distance upon speed. So distance upon speed, so from A to B speed is your 30 and from B to A speed is your 40. So it will be your, and when you calculate this one, you'll get it, what is 34.28 kilometer per hour. And also when you know this speed in V1 V2 forms, you can also by directly formula, when you solve this one, the one formula is also be here, average speed is equal to what is twice V1 V2 upon V1 plus V2. So by this example you can directly solve, but remember the distance should be equal. Distance should be equal. This is very important. Distance should be equal. Distance should be equal. Okay. Similarly, one more example we'll take. Question second. If time intervals are equal when train travels from station A to B and station B to C, and speed in first case is 30 kilometer per hour and next case 40 kilometer per hour. So again we have to find average speed. So find average speed. I think this will be now easy to you. The time are equal in these two intervals and speed are different. Well, again the formula is, remember, is average speed formula is total distance upon total time taken. So we'll take total distance. Total distance we have to calculate in this case because distance are not equal, the time intervals are equal. So we will calculate here, distance are not equal, time interval are equal. In the first cases speed is what is 30. So speed is equal to distance upon time. What we need a distance. So it will be speed into time. So we'll write here 30 into time interval, say equal, I'll take t. Similarly, in the next case, the speed is 40 and time interval are equal. This is t, and the total time interval will be twice t. So t plus t twice t. We'll calculate here. T is common. We'll get it here. 30 plus 40 upon 2. So the average speed will be 35 kilometer per hour. This shows how we calculate average speed. Remember, here we can also make a formula is here, average speed, and the formula will be what is v1 plus v2 upon 2. This will be your formula, but remember, this is only for equal time interval. Equal time interval. Equal time interval. This is a necessary condition. So we've seen some example of average speed.